This is lesson 2.3, part 1. We are going to talk today about key features of a graph. So when you're looking at graphs, there's always certain things that you want to pay attention to because they mean something. So as we get started, we're going to remember the word domain and the word range. So remember that we learned before that domain is the x values or the independent variables, the input, the range, the y values, the dependent variables, the output. And so the first thing we're going to do is we're going to identify domain and range. When you identify domain and range, you are identifying what are the potential input numbers, and then because of that, what are the potential output numbers. We are going to write our ranges in interval notation. So remember, interval notation gives us a range of numbers. So like from 6 to 8 would be if it's inclusive or non-inclusive, whatever it might be. So we would write like something like that. So we're going to write these in interval notation showing from here to here, and we're going to tell whether the function is increasing or decreasing. So just like the words indicate, increasing is something going up and decreasing is going down. And you always go from left to right when you decide if a graph is increasing or decreasing. Okay, so let's start with the easy part of this. So if I look at this graph number 1, this is a linear equation, and the increasing or decreasing part is the easiest part to do. So if we start on the left of the graph, does the line go up or does it go down? And easily you can see that it goes down from left to right. So this is a decreasing function. It also means that this is going to have a negative slope. If you have to write the equation of the line, it's going to have a negative slope, just so you know. Now the domain, because it's the x values, we're going to be looking at what are the potential on the x-axis. This will make more sense as we see different kinds of graphs, and we'll talk a lot about this year and next year. What I'm saying is, like, if I go to 4, is there a graph anywhere above it or below it? Yeah, if you go down to 4 and you go down here to, negative, 10 or so, yeah, that's part of the graph. If you go to 0, there's a graph. If you go to negative 3 and you go up, there's a graph. And so what are all the numbers that it could be? The easiest way that I have found to describe this is if you look at the x-axis as a little sidewalk, and you get a little guy, and he's going to start out here at negative infinity, and he's going to start walking. And as he walks along the sidewalk, can he look up or can he look down and see the line? Now, as he's out there at negative infinity, if he looks up far enough, there will be a line. So he's in the domain. And as he continues walking, he still can look up and see the graph. Here, he can look up and see the graph. Here, he's standing on the graph. Here, he can look down and see the graph. And over here, he can look down and see the graph. And even over here at positive infinity, if he looks down far enough, there's going to be a graph. Okay, so that is all in the domain. And what that means for this particular problem is it means that the domain of this function is from negative infinity to positive infinity, because that's where he can see the graph. So we're going to say x because we're talking about domain, x values. X is an element of the interval from negative infinity to infinity. In other words, all real numbers. Okay, now it says to write it in interval notation, so we're going to write it in interval notation, but it means that you can take whatever the equation for this line is, and you can plug in anything you want for x. Now, the problems that we run into with domain is when you have something like dividing by 0 or taking the square root of a negative number. So when you do something that's not defined, that's where the domain starts to have restrictions on it. We'll see more of that in secondary 2. The range is the opposite. The range is how high does this graph go and how low. So if you look at the highest point of this graph, how high does this graph go? What's the highest point? Not 8, because it keeps on going. So it goes all the way to infinity. And what's the lowest that it goes? Keeps on going, negative infinity. So the range on this, we're going to say y is an element of, because it's range, y values, negative infinity to infinity. Okay, now I will tell you that with lines, so with linear equations, as long as they're not horizontal or vertical, horizontal and vertical are going to be a little bit different, but anything non-horizontal and non-vertical will have a domain of all real numbers, that's always true, and a range of all real numbers. Now, if it's horizontal or vertical, one of those is not going to be true. Okay, let's go to the next one. The next one, we have this graph. This is an exponential graph, and we'll look at these more later on, but this is what an exponential graph would look like. And so it's got a curve to it. It's kind of flattening out here on the left, and it's rising quickly on the right. And all exponential graphs have that type of curve to it, where it flattens out on one side and it rises quickly or drops quickly on the other side. And so that's how we identify what that is. As far as increasing or decreasing, if you start on the left of the graph, is it going up or down? It's going up. So this is going to be an increasing graph. Now for the domain, remember what I told you about the sidewalk. So think about the x-axis as a sidewalk, starting out here at negative infinity. Okay, now obviously he can't look up and see a graph because there isn't any, but could he look down and see a graph? If he looks down, yeah, this graph keeps going. And so the domain is going to start at negative infinity. Now as he keeps walking, still look down, see it, okay, standing on it. Over here, if he looks up far enough, he's going to see the graph. And even over here, he's going to have to look up really far, like get a telescope or something. But if he looks up far enough, this is going to keep on going out. Takes a really long time to get out there, but it will. Notice that with the curve of this exponential, notice how it's moving right as it's moving up. So it keeps going out like that. And so eventually it's going to get out here, but it's going to be really far away. But that is going to be all real numbers. So it's going to go from negative infinity to positive infinity. That's the domain. Here's a secret for exponential equations. So if they look like this on the graph, the domain is going to be all real numbers every time. Now the range is going to be different on this one. So on the range, we are going to have this flattening out part. What that is, and we'll talk about this a little bit later, but it's called an asymptote. And the asymptote is basically kind of an imaginary line that this graph goes up to, but it never quite touches. So it gets really, really close, but it never quite touches. And so that's the low boundary point. So the low part of this is going to be at negative 3. Now how high does it go? This keeps on going up, 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 so it's going to go to infinity. So the range is going to be y as an element of, the low part is negative 3 to infinity. That's your range. So how low does it go and how high does it go? Always put the low part first. Okay, it has to be the smallest number first and then the largest number. Number 3, this also looks like an exponential equation, except it's just kind of flipped. And so this is a form of an exponential equation. We won't actually look at these this year, but it's the same idea. And I can tell because it flattens out on the one side and it drops really quickly on the other side. And that's what exponential equations do. They have that one side that flattens out. And so if you look on the left, can you tell if it's going up or going down from the left to the right? I want you to pause the video and I want you to decide, is it increasing or decreasing? And can you figure out what the domain and range are? So pause the video, come back. Okay, you should have figured out that this is a decreasing graph. It is going down from left to right. And then for the domain, think about walking along the little sidewalk. You can look up and see the graph, and you still can look up. The tricky part is right here, realizing that you can look down, and if you look down far enough, you're going to see the graph. Even over here. It's going to take a really big telescope, but you'll be able to see it. Okay, so the domain on this one is all real numbers, and if you remember also, I told you that exponential equations are going to have a domain of all real numbers. The range, how low does this go? So what's the low point of your graph? The low point, it keeps going forever, so negative infinity. And what's the high point of your graph? This right here is that line I told you about called an asymptote, and that's 3. So when you do the range, you're going to say y is an element of the small number, negative infinity, to 3. These are non-inclusive because this graph, it goes up to negative 3, but it doesn't quite touch it, so it's kind of like floating on top of it almost. And so that's why it's non-inclusive. I should have said that on the last one too. It's non-inclusive because it doesn't actually touch, and that's why we draw it as a dotted line. It doesn't actually touch it. It just gets closer and closer and closer. Okay, number 4, we're back to a linear equation. So pause the video again. Is it increasing, decreasing? What's the domain and range? Okay, you should have determined that this is an increasing graph. It is going up from left to right. Because it is a linear equation, this one hopefully should be easy. The domain is going to be all real numbers. The range is also going to be all real numbers. So it goes from negative infinity to infinity in both dimensions. Okay, the next problem we're going to look at, we have this graph, and it's called graph A. We're going to come back to it in a minute too. But what we see in the graph is we see this exponential graph. Okay, and so the exponential curve, that's how it looks. So you want to start being familiar with that. We're going to start seeing those a lot. Read this paragraph right here. It says an exponential function in the form f of x equals a to the x. Remember that f of x is the same thing as y. A to the x power. So it's something like y is equal to 2 to the x power, y is equal to 3 to the x power, something like that. That's an exponential equation. As long as a is greater than 0. So if you have y is equal to negative 1/2 to the x power, that's not going to look the same. Okay, so it has to be positive right there. So if you had something like that, that would be exponential. But it wouldn't be greater than 0. So y equals 1/2 to the x power, that one actually looks like this. So it's going down, it's decreasing, and we'll talk a lot more about that later on. But if you have a is greater than 0, but it can't be equal to 1, because if you think about it, y is equal to 1 to the x power, 1 to any power is just 1. So that would actually just be a horizontal line, y equals 1, and so that's not an exponential. So to be an exponential equation, it's going to have to look like this and meet these qualifications. So in that case, it has an asymptote, so there's that word again, which is a line that the graph gets closer and closer to, but it never crosses, it never touches. So this is a solid line because that's how the graphing program drew it, but we actually represent it with a dashed line. And as your graph gets closer and closer to it, it looks like it's touching, but we just understand that that is the limitations of the graph. We can't, if we zoomed in close enough, we would see like it's really close, but not quite there. Okay, it says the function in graph A at the right has a horizontal asymptote at y equals negative 4. So negative 1, 2, 3, 4. This is y equals negative 4. That's what this horizontal line is. It may appear as though the graph line touches y equals negative 4, but it actually never does. What are the equations for the asymptotes in examples 2 and 3 on the previous page? So let's go back and look at 2 and 3. So there's 2. What would the equation for this asymptote be right there? It's horizontal. It goes through the y-axis at negative 3. So we would write y equals negative 3. Now let's go back and look at number 3. What would the asymptote be for that one? It goes through the y-axis at 3. So that one is going to be y equals 3. Okay. We are going to pick up this lesson in the last video. And so you can go to that video and continue the rest of the lesson.